Hello everyone, this is Greg from ChemCore. In this video, we're going to be going over the common names worksheet. If you haven't watched the instructional video on this topic, it's linked in the description below. And if you haven't seen the worksheet that we're doing here, it's also linked for free in the description below, as well as an answer key that we'll eventually get to later. Now, some of the common names that you might remember from the instructional video have to do with either the 4 or 3 or 5 carbon groups, specifically propane, butane, and pentane. And I want to specify that some confusion may be that the common names are more important when they're attached to a larger group. And so when they're attached, we have talked about some IUPAC naming before. If you're attached to a larger group, you have to name it as a substituent. And so that's when these common names become, important. It's the fact that we see these that's why they're called common. We see these groups repeating in molecules so many times that it becomes common, and we could just use a common name to describe them. And it becomes important when we have a non-hydrocarbon substituent, like if it's attached directly to an alcohol or a hydroxyl group, or some of the functional groups that we talked about in the past. Now, it's important, some of the questions that I included in this worksheet, it's important to kind of conceptualize that common names are just another name for something that could be described as an IUPAC name. Now, in most courses, if you're given a common hydrocarbon as a substituent of a larger hydrocarbon chain, you won't be allowed to use a common name because it's not the IUPAC name. And so before going on and before doing some questions on your own time and before doing an exam, I really suggest talking to your faculty or your professor or your TA and asking what is required of you. I remember in my course, I was not allowed to use a common name unless explicitly stated, unless it was like connected to a larger or a more a non-hydrocarbon functional group, which we'll talk about kind of later in this course, maybe most of all in Orgo 2. Now, first of all, which of these is the common name for the 1,1-dimethyl-propyl group? And so the easiest way to do this is, well, let's turn this into an actual molecule, right? So using the same IUPAC rules that we learned before, this is a propyl, right? Which means that we have 3 carbons. Okay, and we'll just draw as a little, almost a triangle, and 1,1-dimethyl, which means that we have 2 methyls on the number 1 carbon. So it should look something like this. And now you can realize that, okay, how many carbons do we have in total? I think that's a really good tip. 3, 4, 5. And so we have 5 carbons in total, which means right away we can eliminate anything that has to do with non-5 carbon groups, which means we're eliminating butyl. Now, it's important, this is the most important part, is understanding what your IUPAC, what your common names really mean in terms of attachment. I want to go to isopentyl first, and the reason why I'm skipping B, you might figure out why I'm skipping B, but what I really want to focus is isopentyl. Now, isopentyl could be described as looking like so. And now this looks really similar to what we just drew, but notice that we have the squiggly line on the other side. And why do I say the other side? Nothing in our drawing told us that where the squiggly line should be. Is it here or is it here, right? And remember that a squiggly line means connected to a larger group. Where is it connected to? Well, even though they don't explicitly tell us, they actually do. Notice that they told us that this is 1,1-dimethylpropyl, which means that this carbon was our number 1 carbon. And I'll think about it, if we were connected to a larger group from here, and we were counting and we were giving numbers to our molecule like we do with our IUPAC naming, we would start by giving this the number 1. If it were connected on the other side, well, then this would be the number 1. And so we know that our common name, right? Our 1,1-dimethylpropyl, this common name, this common group, should be connected to a larger group by this carbon, right over here. Okay, and so the isopentyl cannot be true, because then that would mean that would be connected on the other side. It should be, in that case, 3,3-dimethylpropyl. Then the next option, neopentyl, looks somewhat similar, but also clearly different, in which we have something like this. Should be like that, right? 1, 2, 3, 4. Nope, I drew it correctly at first. That's the reason why you should number your carbons. 1, 2, 3, 4, 5. So 5 carbons. This is a neopentyl group. And notice that we're kind of, we mean 3 carbons kind of further away from the larger group. And so we can eliminate that immediately. Now, sec-pentyl actually isn't a thing. And I want to show you an example why. So let's say that we have a pentyl group, right? Sec-pentyl, I want you to realize that sec just means secondary, right? And so what you can understand from this name and understanding what sec-propyl or sec-butyl means is that it should be attached, the larger group should be attached to a secondary carbon, which means any of these carbons. Okay, any of these three in the middle. However, these two, right, the ones that I'm pointing to, are exactly the same, right? So we really could just bring it down to 2. That's the reason why it doesn't exist. By saying sec-pentyl, it doesn't actually tell us enough, right? Saying sec-pentyl can mean, okay, this group is either connected to the number 2 carbon or the number 3 carbon, and both would be correct, right? Both would be correct saying sec-pentyl. So we say that sec-pentyl as a common name is an ambiguous name, and that will never be the answer to any of your choices. Okay, it's not a thing. Okay, this isn't a common name, and we actually do necessarily have to use an IUPAC name. It would be cool if we kind of devised a common name, saying that this is sec1 or sec2, like thing 1, thing 2, but we don't have something like that. So we can eliminate E. The only thing we're left with is B, which actually perfectly describes what we have. And this drawing I have is a little small, so let me just make it a little bigger. So this is our pentyl group. Let me try a different color. Okay, so maybe in a different color we can see that this would be our larger group, right? This is our larger group connecting. Now I want you to notice that by just understanding what the prefixes mean, you can actually figure out what the name is. And so notice that this carbon, right, the one that's being attached to the larger group, has 3 carbons around it. 1, 2, 3, meaning that it's a tertiary carbon, right? The common name itself is tertiary. And so why do you think it's called tert-pentyl? You know, it becomes almost very intuitive to why it's called tert-pentyl. Notice that tert-pentyl and neopentyl are actually opposites. So if it would be attached on this carbon, it would be, you know, tert-pentyl, and if it would be attached on the other carbon, it would be neopentyl. Okay, now the next question, isopentyl is the common name for which alkyl group? Before even figuring out anything about your common names, I want you to eliminate the most obvious wrong answers. And the most obvious wrong answers is the answers that have the wrong number of carbons. Pentyl is telling us that we need 5 carbons. So let's find the answer choices that don't have 5 carbons, and then we can kind of narrow down our choices to the groups that are actually pentyl, right? So I have 1, 2, 3, 4, 5. That's good. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Unfortunately for us, they all have 5 carbons. So now we actually have to figure out which one is isopentyl. Notice that sometimes I don't like these drawings. I like to actually draw it as a bond line. I think by now all of you guys might, you know, feel the same way, seeing as you've been drawing bond lines for maybe a month or 2. And so looking at this might be a lot easier. This is our larger group, right? We can see that kind of being connected over here. And so it's being connected to this carbon. I want you to notice that, like, the easy trick is that this carbon is connected to 2 other carbons, right? And so this should actually be sec-pentyl. This would be a sec-pentyl group, which actually doesn't exist, because what's telling us that we can't attach to the other carbon, right? It doesn't make sense. So we can eliminate A. Then the next group, I'm going to draw it out. We have 4 carbons on the top, and then this larger group is being connected over here, like that. 1, 2, 3, 4, 5. Yep. So our larger group is connected to this carbon. And notice that our extra carbon right over here, that other carbon, not extra carbon, is connected right into the middle, or carbon 2. That's not the definition of isopentyl. I want you guys to realize that even though that's very similar, isopentyl is actually this. And I like to think of it as kind of like isolated. So any of the iso groups, whether it's isobutyl or anything else, is in terms of the larger group is as far away from, I think, like the sticking out carbon. So this carbon is sticking out. It is as far away as possible from this group. And that's not what's going on here. So we can eliminate B. Now C would actually be, seems like, our answer choice, which we have 4 on the top. And we have this pointing, I drew it pointing up, but realized it's the same thing. And so this is the exact image that we drew, in which this carbon group's pointing up is as far away as possible from our larger group. And so we can probably think that this might be our answer choice. But let's draw out the rest. It can't hurt to practice. And so we have 3 carbons on the top. This is going to be our larger group. And then we have 2 carbons on the bottom. We have 1, 2, 3, 4, 5. We drew the carbon correctly. Notice that this is our carbon being connected, and it's connected to 2 other carbons, which means this is another sec-pentyl group. This doesn't exist, right? This is not a real thing. It's almost similar. This is the exact thing I was talking about. A and D would end up being the same exact things, but they're clearly not, right? If we were to give them a common name, like to think about it, we would maybe think, okay, maybe this is sec-pentyl, but then you can realize where the issue arises, in which saying sec-pentyl doesn't actually tell us what the structure is. It could be either of these, and they would both be correct, right? And so the last one would be have 3 carbons, like that, and 1 being connected like that. And then we have 2 carbons coming off the middle. 1, 2, 3, 4, 5. Perfect. Now notice that our tertiary carbon is as far away as possible. So this is neopentyl, right? This is actually the opposite. I like to think of it as the opposite of tert-pentyl, which they look kind of similar, but the attachment is on the other side. Tert-pentyl would be attached to one of these carbons, okay? And so this is neopentyl. We can eliminate E. So our answer choice is C. Question 3, which one of these common names is ambiguous or does not refer to one specific group? And this is something that I mentioned in the previous 2 problems. If you're skipping to this question, I really suggest you watch the first 2 questions because it'll make sense, in which saying sec-pentyl doesn't actually mean anything. Because if we think about what sec means, it means attached to a secondary carbon. And if I were to kind of think about how that could work, that means that this larger group can be attached to one of these carbons, right? C1, C2, or C3. And saying sec-pentyl could mean either of the 2, meaning that, it's not a good common name. So this actually doesn't exist. We'd never use sec-pentyl unless we're trying to trick you or give you an answer choice. But it's not an actual thing. In the next question, we're being asked what is a correct name for the following compound. Now notice I worded this specifically. I didn't say IUPAC name. It's not an IUPAC name, and which if you look at all the answer choices, all of them have common names, which you're kind of thinking, okay, maybe one of these substituents is a common group, and it is, right? We're going to see that very soon. I want you to remember your checklist for IUPAC naming. If you're not sure what I'm talking about, I really suggest you go watch the previous explainer or one of the previous explainers about IUPAC naming. I have a really great system for being able to name IUPAC names, and it pretty much clears you of making stupid mistakes. The first thing that I like to do is I like to identify the parent chain. I'm going to do that with a little highlighter. And so I'm going to try to find the larger group. At this point, I think it's going to be easy to see that it could be one of these, right? Or maybe 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think this looks like it could be the longest chain. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that has 8. What if we do this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the longest chain, right? We have 9 carbons. So what we can actually do is what I like to do is I like to go through the answer choices and eliminate anything that doesn't say no name. It'll give you the name, the answer choice, right? Right away we can kind of tell that the answer is E just from knowing the parent chain. Congratulations. But for practice, I still want to figure out how to name this. And so we have 2 options for numbering this molecule. We can either number from this way, or we can number from this way. I want you to try it like I taught you guys before, but I'm just going to tell you that the numbering should occur from this way, because we're going to end up with the lowest overall numbers. Okay, meaning that, first of all, let's write that our compound is nonane. At the 3 position, we have a methyl substituent. And at the 4 position, we have an isopropyl. Okay, now notice that if we name alphabetical order, we have to name isopropyl first. And so it would end up being 4 isopropyl, 3 methyl, nonane. And that's our answer choice, E. Okay, and so without even kind of just using these tricks, sometimes you'll get lucky and you'll have an answer choice which none of the others follow. Most of the time you won't. I guess maybe I gave you a freebie. I don't even remember the rest of the questions. We're about to find out. But there's a reason why I like to give you these little tricks to figure out the IUPAC name It comes from trial and error and teaching a lot of students. The next question, we're providing a name again for the following compound. Again, we're not giving an IUPAC name. So the first step, what I like to do is to find the longest chain. It might be this one. 1, 2, 3, 4, 5, 6. Okay. Maybe this one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. That's the longest name, longest chain. So 7 is the longest chain, meaning that we can eliminate anything that starts with hexane or ends with hexane because that's wrong. Now, what I can tell you is that the next step, let's write heptane actually. The next step, what I like to teach you is to try numbering it from both directions and see which gives you the overall. But what I'll tell you is that you should name from this direction. I want you guys to try it the way I taught you guys. But for now, I'll do it like this. Notice that on number 2, we have a methyl substituent. On number 5, we have a methyl substituent. And number 4, right over here, I kind of missed it. We have another isopropyl substituent. And so we should actually name this as 4-isopropyl, because that comes first alphabetically. And then 2,5-dimethyl, don't forget your prefixes, heptane. And that perfectly corresponds with answer choice D. Question 6. What is the common name of the following substituent? Notice that this is our parent chain. It's the same way as saying like one of these squiggly lines that I did before. We have 4 carbons, 1, 2, 3, 4. So I know that one of our answer choices has to be with butyl, something with butyl. And a little trick that I like to do so you don't like kind of visually memorize anything is to look at the carbon that it's attached to. This is the carbon that it's attached to, and it's connected to 2 other carbons, meaning that it's secondary, right? In other words, sec-butyl. So our answer is D. Which of the following is a tert-butyl group? The first thing I like to do is eliminate anything that doesn't have 4 carbons. This has 4 carbons, 1, 2, 3, 4, that's good. This does not, 1, 2, 3, that's wrong. And we can eliminate 2, right? And this should be numbered. I think it's pretty obvious. 1, 2, 3, 4, okay. 1, 2, 3, 4, 5, that's wrong. We can eliminate 4. 1, 2, 3, we can eliminate 5. So now we're in between this one and this one. Notice that tert-butyl, you can kind of understand, okay, it's probably connected to a tertiary carbon, which perfectly makes sense. This is our carbon that the parent group is attached to. It's connected to 2 other carbons, meaning that it's secondary. While on this one, this carbon is being attached to and is connected to 3 other carbons, meaning that it's tertiary. And so our answer is C. Okay, in problem number 8, we're tasked with writing the IUPAC name for each of the following structures, and kind of a side task that I've given is to practice highlighting primary, secondary, tertiary, and quaternary, because I feel like it's useful to really keep that in mind when making common names. Because as I said previously in this video, and if you haven't caught that part, maybe skip back a little bit, a lot of the common names can really just be figured out by knowing whether a carbon is secondary, tertiary, or quaternary. That's to an extent. Some of the exceptions that I talked about earlier follow that, and I hope that's clear by now. So let's highlight all the primary carbons in blue. A really good trick for highlighting primary carbons is let's just find all the terminal carbons, right? So all the terminal, by terminal you'll see that word a lot, in which they're at the end, right? They're the terminal. Now for the secondary, we could just find all of the carbons that are attached to 2 other carbons. So I think this should cover all of them. And now tertiary carbons are everything that we have in green. It includes that carbon in the middle. And we don't have any quaternary carbons. Okay, and I'll write the name down using blue, but realize that that's not part of the original problem. First of all, let's find out what our long or parent chain is. And so what we can do is we can 1, 2, 3, 4, 5, 6, 7, 8, 9. I actually forgot one of the carbons here. Okay, so we already found 9. what about here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That looks like it's going to be our longest chain. Okay, and so we now know that that should be decane. So like I usually do, let's write our parent chain somewhere along the side. And now the task is whether to number from going this way or number going this way. And let me just leave the highlighter on so it's going to be easier for you guys to see. This is our parent chain, that decane that we found. Okay, one of the options that we can number from this direction going this way, or we can number from this direction going this way. And now I suggest you guys pause the video at this point and really try to figure out the numbering by itself. But what I'll tell you is that we should be numbering from the right direction, and this will give this substituent the number 5 and this substituent the number 6. So at the 5th carbon, the 5th position, we have a methyl. And at the 6th position, we have just a regular propyl, right? Doesn't look like any common name. And so if we have to put that in alphabetical order, let me put that on the bottom where we have more space. It's going to be 5-methyl, 6-propyl decane. Okay, and that is our final IUPAC name. The next problem, let's go ahead with the same thing. So these are our terminal carbons. We got 4 of them. Our secondary carbons are going to be these guys in the middle. And we have 2 tertiary carbons right over here. And again, no quaternary carbons. Again, let's try to find our parent chain. So let's just try from here. 1, 2, 3, 4, 5, 6, 7. And that does look like it's going to be our longest chain. Let me just fix that, make it a little cleaner. I think any other option is going to be a little smaller. And so again, I suggest you pause the video. And again, I forgot to mark one of the carbons. This is a secondary carbon right over here. I suggest you stop the video at this point to try to figure out the numbering. We can either number from left to right going this way or from right to left going this way. And remember that we want to give all the substituents an overall lower number. And so after hopefully pausing the video, you should figure out that we should be numbering from left to right to give this substituent the number 2 and this substituent the number 5. And then remember that 1, 2, 3, 4, 5, 6, 7, our parent chain was heptane. On the number 2 position, we have methyl. And on the number 5 position, we also have methyl. And so this should be named 2,5-dimethyl heptane. Alrighty. Okay, in the next problem, again, let's find all the terminal carbons. Those are going to be our primary carbons. So these guys. Now in green, let's mark down all our tertiary. We actually wouldn't have any secondary. So no matter how hard you look, you won't find any secondary carbons. Now if we were just to highlight, let's try this. 1, 2, 3, 4, 5, 6, 7. Clearly, like, this should be the longest chain. And let's write down that our parent chain was heptane. Okay. Again, I suggest you pause the video at this point to figure out what our... Again, at this point, I suggest you pause the video to figure out what our numbering is. But I want you to realize that on the 2nd position, 3rd position, 4th position, 5th position, and 6th position, we'll have methyls. It actually doesn't matter whether you number it from left to right. It'll end up being the same thing. So we have 2, 3, 4, 5, 6, penta. This is a cool practice for your prefixes. Pentamethyl heptane. Okay, in the next problem, again, let's mark down our little terminals. Terminal carbons, it's over here. These guys. All right. And now our tertiary carbons, should be these guys. And we actually have 2 secondary carbons right over here. Now let's try to highlight and find the parent chain. That's 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6. Yeah, it looks like that should be our parent chain, the seven carbons. Let's write down on the side that we have heptane as our parent chain. At this point, pause the video, try to figure out the numbering, but I will tell you that we should have this in our 2 position, 3rd position, 4th position, and 5th position. So at 2, 3, and 5, we have 3 methyls, meaning trimethyl. And on the 4th position, we have ethyl, meaning that if we put this in alphabetical order, we will have 4 ethyl, 2, 3, 5, trimethyl, heptane. All right, the last page of our practice sheet. Let's find the terminal carbons. I see one here, 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 and here. And I see some secondary carbons, a lot of secondary carbons. Right over here. Okie dokie. And then we just have 2 tertiary carbons left. Tertiary carbons left right over here. Okay, and let's try to find our parent chain. So it looks like it might be this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's definitely going to be our longest chain. You guys can try if you want. That means our parent chain is decane. Again, I suggest you stop, try to figure out their numbering. The numbers should be the 4 on this substituent. Where's my pen not drawing? There we go. And a 7 on this position, which means on 4 we have ethyl, and on 7 we have methyl. And so if we were to organize this in alphabetical order, it comes out to be 4 ethyl, 7 methyl, decane. Problem after that, we have tertiary carbon here, 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 and also these 3. I see some secondaries right over here, these 3 guys. I see a tertiary right over here, and I also see a quaternary, right, for the first time in our practice sheet. Now, I want you to know that, pause here, because the highlighting might mess this up. Okay, let's try to find our parent chain. Maybe this. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Okay, what about this? 1, 2, 3, 4, 5, 6, 7. Yeah, I think that's going to be our longest chain. And so our parent chain should be heptane. Try to number by yourself, but I'll tell you that we have these 2 substituents on the number 1 carbon. Try to number on your own, but realize that we have these 2 substituents on the number 2 carbon. This ethyl is on the 4 carbon, and these 2 are going to be on the number 6 carbons, meaning that we have 4 ethyl, and then we have 2, 2, 6, 6 tetra methyl. Good practice for your prefixes. And so if we were to organize in alphabetical order, it should come out to be 4 ethyl, 2, 2, 6, 6 tetra methylheptane. Okay. Okay, in the next problem, let's find all our terminal carbons. I see these guys, as well as these over here. Let's find our secondary carbons. Should be this. That's all I see. And our tertiary and I don't see any quaternary. So let's try to find our parent chain. Should be something like this. 1, 2, 3, 4, 5, 6, 7. Looks like it probably is our longest chain, meaning that our parent chain name is heptane. Okay, now practice numbering on your own, but realize that our numbering should be 2, 3, then 5, and then 6. And so 2, 3, 5, 6, tetramethyl, meaning that our full name should be 2, 3, 5, 6, tetramethyl heptane. Okie dokie. The next problem, our terminal carbons are right over here. Okay, our secondary carbons are here. Oh, one more secondary carbon. I actually don't see any tertiary, but I do see 2 quaternary carbons. And it looks like our parent chain should be 1, 2, 3, 4, 5, 6, 7. Yeah, that's definitely our longest chain. And so the name of that is heptane. And I should ask you to try to name it on your own, but realize that our number should be 3, 3, 4, and 4. Okay, meaning that we have an ethyl on the 4th position, and then we have 3, 3, 4 trimethyl. All right, and our full name should be 4-ethyl, and then 3, 3, 4 trimethyl heptane. Okay, and the last 2 problems, almost there, the home stretch. We have our terminal carbons right over here. Okay, we have a lot of secondary carbons, look at that. Okay, and we have 2 tertiary carbons right over here. So our parent chain is probably going to be this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, decane is our parent chain. Okay, and we have a methyl or an ethyl on the 3 and a methyl on the 4. So let's write that down. We have ethyl on the 3 and methyl on the 4. And final step, let's organize it all in alphabetical order. So in total, the name is 3-ethyl, 4-methyl, decane. Okay, and the last problem, I have a terminal carbon here, here, here. I have some secondary carbons and a tertiary carbon right over here. And let's try to find our parent chain. 1, 2, 3, 4, 5, 6, 7. That was a pretty easy one. So our parent chain name is heptane. Heptane. And all we do is we have a methyl on the 2nd position. I think that's pretty easy. Shouldn't be too much work for you guys. And so the total name should be 2-methyl heptane. All right, guys, that concludes the worksheet for the common names. If you haven't seen the instructional video, again, it's in the description below. I really suggest you guys go watch that. If you haven't had a chance to look at this worksheet or the answer key, it is also in the description below. Feel free to practice again and maybe to try again on some of the principles that we talked about in this video. And I'll see you guys in the next video.